flip it down. So that must be a reflection along the x-axis. Then the other one is for the second one. Is it A or B, right? Am I making sense? So don't try to memorize. Just go with the flow this way. Okay? I don't like to memorize. I know there are twins, right? So once I can identify A, I can identify B. Okay? And maybe with time, you get used to which is which. Okay? Alright. So, the last 15 minutes of the class here. Thank you. Go start with C, not yet. Start with C. Okay? Start with C. C is reflection, so it's very easy. Start with C. C is very easy, so it's a reflection. Start with that. So I just put 3 questions. One on the reflection on the x-axis, reflection on the y-axis. I just put 3 questions of each. So start with C. Then I'm going to write the summary here. You're welcome to collaborate, please. But focus on what you're doing and do it fast. Guys, the reason I want you to focus on greater than 0 is because when you have a negative, you're talking about the reflection. And since the reflection is a separate discussion, that's why I insisted this must be greater than 0. Okay? But if it is negative, you are mixing the investigation 2 and 3 together. But let's see them separately. Okay?
Mr. Daniel,
yes.
What is the origin of stretch or whatever it's called?
What?
You know when you're stretching, you need like a point and a scale factor. Where's the point for stretching these things?
The line The x-axis or the y-axis? Your distance is from the x-axis or from the y-axis?
Oh.
So just focus on the distance from the x-axis.
Oh, I get it now. Okay, thank you.
Okay? If you have this, look, you have this. If this is your x and y axis, and you want to stretch, so if this is, say, this is 0, and this is 6, for example, this is y is equal to f of x. If I'm trying to do y is equal to f of 2x, it means half of what it used to be, right? Clearly, everything will pass through the intercept, which I have not seen here, right? So everything will pass through here.
Yeah.
Every point here must be half from the beginning. So if this was 2, then the new one must be 1. If this was 8, then the new one must be 4. On the x-axis, you measure like that. If this is 6, oh, the new one must be 3.
Yeah, okay.
If this is, let's say 3, the new one was 1.5.
Yeah, okay.
So 3 and 1.5 will be the new one, like that.
Yeah.
And also you have to take care of the
Vertex.
vertex. If the vertex, because this is 6 and, okay, I don't know what this one is. If this is 1 and this is 6, the vertex will be at, what? 3.5.
Yeah.
So half of 3.5 will be 1.75, something like this. So your vertex will also come this way. Okay? So you consider all the point, the major point exactly that the curve passes through. You consider it along this side. That's how you sketch successfully. I hope everybody understands how to sketch this stretching. The reflection is not the problem, it's that stretching, the dilation that might be a problem. Okay? Can I explain something? Can I explain something, please? Something to help us. Can I explain something, please, quickly?
Yes.
So you have this, Joey. So you have this, please look up. It might be something you already know, but I don't want to assume. After this discussion we just had, I thought it's necessary I tell everyone as well. So let's say this is the original function, which passes through -4 and 6, for example. It means the vertex will be where?
1.
1. So the vertex will be at 1, comma something, depending on what the original stuff is. Okay? So 1, comma, but we don't know we only know this. We don't know the intercept. Understand? We don't know the intercept. So 1, comma some y1. Okay? Please listen. Now, this is the graph of y equals f of x. Now I'm interested in the graph of y equals to f of 2x. It means I'm going to stretch it with a scale factor of what? Speak louder, please. 1 over 2. And I will have which invariant point?
1.
Which point would be invariant?
-4.
Which point is invariant?
X intercepts. So Y intercepts.
Y-intercept, x-intercept, which one?
Y intercepts.
Y-intercept will be the invariant point, which is here.
Yes.
So my original graph is also going to pass through this. What you will now do, you consider, because we are going to do halfway, right? From here.
Yes.
Hello? Halfway from here. You consider major points. Major x points. Because x is moving. Only y is not moving. That's why we say y invariant. Hello?
Yeah.
Y invariant means y does not move. So consider every major point x. What are the major points x? X is equal to 6. X is equal to -4. X is equal to 1. In fact, some of the point that passes through here, if it passes through a whole number on the graph, am I making sense?
Yes.
So if it passes through this, you know the other one on this line will be 3.
Yes.
If it passes through this, you know you are dealing with -2. If it passes through 1, you know you are dealing with 0 on the same line.
Yeah.
Hello?
Yeah.
On the same line.
Yes.
You pass through this.
0.5.
0.5. So now you have this, you have this, you have this.
Yeah.
And then it must pass through the y-intercept.
Yeah.
So if I'm sketching now, I will go this way, pass through the y-intercept. It's now going to turn here, and it's going to pass through that, Are you with me?
Yeah.
Then I will monitor this. If this happens to be some x is equal to 7,
Yeah.
I will make sure this passes through 3.5. If this happens to be some x is equal to maybe minus 6, I will make sure this passes through minus 3.
Yeah.
And that is how you will have a more meaningful sketch. And similarly, if the stretch is on the other side, let's do one of that. I have this, the same curve. Okay, the same curve, I have this. Are you with me?
Yeah.
And we are interested in we are interested in maybe 2 f of x. Let me make it half f of x. Okay, 3 f of x. That would be too much, right? Okay, half f of x. That's halfway. Because for this one, half is the scale factor. For this one also, half is the scale factor, even though it looks different. You have to be able to differentiate between the two.
Yeah.
All right. If half is the scale factor, but on this axis, so it means I'm going to reduce it. Let's just make it 2. It means I'm going to stretch it down, double the distance here. Okay? Now, we already know that this is 1 comma some y1. It means it must get to the point 2y1 down here. The same point must pass through this. But this time around, it is x invariant. So the x does not change. It is still x is equal to 1. And remember, it also passes through this. So all my points will also pass through this. Do you agree?
Yeah.
So x invariant. So what you will do, important points, measure them along the y-axis exactly twice. For example, this point, hello, this point, if this point is y is equal to 2, double will be y is equal to 4, right? So my curve will pass through y is equal to 4. Okay? My curve will pass through y is equal to 4. If this point is, now this point is based on the same value of x. Hello? When x is equal to some x1, I get y is equal to 2. On the same x1, you get y is equal to 4. Because x is invariant, x does not change. Only the distance on the y-axis will change. Am I making sense?
Yeah.
So you really want to consider these important features. So you don't just sketch something and you get, not an optimal, a maximum score. Understand?
Yeah.
All right. So you may focus on your work now, while I focus on my notes.
Yeah, I shut this.
This same thing applies to.
Oh, we've done before.
No. I'm writing because we will need the notes. So just focus here.
Okay.
This same thing applies to other functions, even though we are dealing with algebraic functions. If you have exponential function, the same thing. You have logarithmic function, the same thing. You have trig function like sine, cos, the same thing happens. That's why there was no specification. We just said transformation of functions. We didn't differentiate which function.
Yes.
Understand?
Yes.
If you are done with the stretching, you can go to the B part now. Oh, no, did I ask you to do the reflection first, then go to the stretching after that? Okay. I just thought you'd do something easy first, so you don't get discouraged. Okay. Please do the work in class. Don't copy notes in class. Do the work in class so you can share ideas, you can ask questions. Okay, you can always write the note at home. It's going to be on the video, and I'm going to send pictures of the board.
No, see, this is you can move x and not cannot move the y. Right, so you move this is 1, 2, 6 over 3. So this one, and this is also the 1.
I didn't consider when p is equal to 1. Can somebody tell me why? It's going to be the same function, right? So that's why in that interval, p is equal to 1 was never, is not an option. We have PE today, yes?
Yes.
Okay, so I would let you go in about 2 minutes. Joey?
Yes. Shut the camera.
No, over here.
Oh, okay.
I still have the notes. Okay, I'll be fast with my notes. Did I put remain over there or remains?
Remains.
That S shouldn't be there. Yeah, remain. Okay, it's 5:03. Okay, maybe you can go. I will stop that when I'm done because I want that the notes captured as well. And please be mindful of your movements. So you can go for your PE.
Wait, King, the effort mark 係 P 落幾多？
Oh, me too.
No, 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 no. Just for the for the caller to say that I don't know her.
how do you get A, B?
Like I said, I'm recording, so be mindful. That's a movement.
I got a 30. I mean, it's not 4. It's pretty bad. Where's that from? What are you Yeah, I know. I know Africa is. Should be. What do you call it? It's Toto by Africa.
Sounds so popular they made it popular.
I know, right? Very soft. What is that? Football. Football. Goodbye, Mr. Daniel. See you
Bye. See you.
This part.
Oh.
Yeah, you don't want to. You don't want. And you still get tired.
Why S is the V?
I'm going to do a daily login user right. Really? I don't know how you level up.
Never
much
done it. Never done it.
Today I teach how to.
即係我都唔知啊。係個 job 係個 photo。
Take a photo.
My phone has no back, all 6%.
Miss Kelly, it's time for PE. Yes, ma'am. Yes, sir. So make sure everything is everything captured. Okay, great. So you can turn it off now.